Hello students, I am your course instructor Professor Anisa Shikalkar. In today's video we are going to see about the derivation tree. So the students, we have seen the grammar. Grammar is defined by four tuples, that is V, T, P and S. So here one kind of example of grammar is given, that is V, T, production rule and S. V is nothing but the non-terminal symbols, T terminal symbols, then production rule and start symbol. So here derivation is of having three types as we have seen in the previous lecture. The first type is the leftmost derivation, second rightmost derivation, and we are now at the third type, that is the derivation tree, which is also called as a parse tree. Okay, so here what is exactly derivation tree? Here derivation tree is the graphical representation for the whatever the strings we have derived by using the different production rules. Okay, so here one example is given, grammar, then production rules are given, and they have asked one string to be derived by using the derivation tree. Okay, so here how that particular string can be derived by using the derivation tree. So starting from the start symbol. So here that is our root node. So remember student, starting symbol S is always the root node in the derivation tree, or which is called as a parse tree. So here S is the starting symbol. After starting symbol, here I can write as the root node. Okay. After starting symbol, then the next whatever the vertex are there, that all vertex are nothing but the here V. V is nothing but the non-terminals. Okay. So here S produces two production rules are there. One is the S produces AAS and another is S produces small a. So for each and every step, look at the string which we are going to prepare for the as your answer. So that is the AA, BB, AA. That string we are going to generate. So in between these two rules, it is that particular rule which we can use at the first step, that is S produces AAS. So here we can make our derivation tree like this, A and S. So the students, that A is nothing but terminal symbol which is called as a leaf node, Okay, and here these two vertex are nothing but the non-terminals. So here for that non-terminals we are different production rules, and by using these kind of production rules our here task is to generate that particular string. Okay, so the first symbol here I can write as this, which is our first symbol in the string which we are going to derive. Then the next vertex is capital A. So capital A, here for the capital A there are three production rules. The first is the A produces SBA, A produces SS and A produces BA. So out of these three we can use any of the production rule, but what we are going to see here, we are going to observe our string which we are going to generate. So the next what I want, small a, then B. So here capital A produces, suppose if I use SBA and that particularly S produces A, so here I can be more closer to the string which I want to generate. Okay, so here again A produces S, B, A. Okay, now that is our vertex non-terminal for which I can use S produces A, that production rule. So here S produces A. Now it is my leaf node, second leaf node, which is the second symbol from my string. Okay, then that B is the third symbol of my string. The two vertex are remaining, A and S, and still BAA, that particular string is remaining. So A produces, what I can use here, we can use A produces BA, so that particular BA will be completed, and remaining S is there, so S produces A. If we can use in that particular way, we can completely generate that string AA, BB, AA. So here students, what we have decided, S produces B, A. So these are terminals, means leaf nodes, and S produces small a. So here if we can observe, we have generated the string which they have asked in the question, that is AA, BB, AA. So that is called as a derivation tree. So here we can observe that particular as a derivation tree. In that derivation tree, the root node is the starting symbol. After the root node, the vertex nodes are there. Vertex nodes means the nodes which are having the child nodes. Okay. So vertex nodes are always the non-terminal, and the child nodes means they didn't have any leaf. So here that particular leaves are called as a leaf node. That leaf nodes are the terminals. So from our grammar, it is starting symbol, then vertex are non-terminal, and leaf nodes are the terminal. So here that particular is called as a derivation tree. Here they have asked one question in which grammar is given, production rules are given, and one string is asked to be derived by using the derivation tree. So the students, in that derivation tree also there are two types. So what are those two types? Left derivation tree and the second is right derivation tree. Okay. So here we will see what is that left derivation tree and right derivation tree. In previous video we have seen leftmost here derivation and rightmost derivation. So similar to that, suppose it is the question to be asked. So in that particular, it is the root node. We have derived that particular production rule, S produces A, S. So in between these three nodes, which is the leftmost non-terminal? So here it is the terminal. So we are not using that particular. Capital A and capital S. These two are the non-terminals, and out of these two, which is our leftmost non-terminal? That A. That particular A is the leftmost non-terminal, and we are always replacing the leftmost non-terminal. That kind of derivation is called as a left derivation tree. So here, suppose in between these three, we are replacing that particular capital A by using SBA, then S, that is terminal node, capital A is the non-terminal. So S and A, these are the two non-terminals. Out of these two, that particular S is the leftmost non-terminal. So here if you can observe, I have always replaces the left non-terminal. Here we can, it is also possible that I can replace that S by A and then we can move towards the next. But here what I have prepared, left derivation tree. So S produces S, B, A. In that I have replaces that S first, then that particular A. After that the remaining S. So the derivation tree which you have seen on the board is the example of the left derivation tree. Okay. So here if I want to use the right derivation tree, so what changes we require in that particular? So first I can replace that S. Instead of that A, first replace that S by the production rules, because in between that A and S, S is the rightmost non-terminal, and for right derivation tree always replace the right non-terminal, rightmost non-terminal. So here after replacing that S, then move towards that particular A. So if that A will be replaced by SBA, here two non-terminals are there, S and A. So out of those two non-terminals, again prefer rightmost non-terminal, which is that A. So always replacing rightmost non-terminal is nothing but the right derivation tree, and always replacing the leftmost non-terminal is nothing but the left derivation tree. So that is one example which we have seen for the derivation tree. In the next video, I will show you the another example for the derivation tree, which is also called as a parse tree. Thank you, students.